All right, guys, sorry. What was the question, sir?
4.1, number 9.
Oh, so this one is.
I was plugging in the numbers.
Yep.
But like I didn't know if we needed to make it get rid of negative 2 over y.
It's a good question because people always do too much with this problem. They give you this point. This is number 9, page 254. And they say, check this. Is this a solution to this equation?
So I was plugging in, but then I didn't know if we needed to divide. Well,
No, just plug them in. See if they work. So, for example, if I plug it into the first guy here, 2 times what? I mean, negative 2. Sorry.
negative 2 times 6.
Negative 2 times
6.
y. And what's y?
Oh, negative 8.
Negative 8 equals x 6
plus 10.
plus 10. Cool. So be careful. Put the y in the y place, the x in the x place. So be really careful about that. Is that true?
Oh, okay.
16 equals 16. Check. So then you move on, right? And say, yay, that's true. It's good.
Yeah.
Get to the next problem.
But then what if the second
Be
one
very
doesn't work?
sarcastic.
Yeah. So you do the
Yeah.
same thing.
So what else has happened? I mean, to be a solution to this system, that point has got to work in both, right? That's the idea. It's got to be on one line and the other line. It's got to be where they meet. So does it work in the other one? 3 times what?
Negative 8.
Negative 8. Equal to 2 times x 6. That looks like it doesn't have much chance, right? Positive, negative. Negative 24, does that equal to 42?
No.
Oh, so
No.
it doesn't work.
So this point, I really want you to understand, these two lines probably meet somewhere, but that point is like here. Where is the answer to this system of equations? It's of course where they meet. So just because that point works on this line, there's an infinite number of points that work on that line. Ooh. The reason these are harder than that is because you have to make it work on both lines at the same time.
Okay.
So it worked on there, but it didn't work on there, so it's some point off to the side.
So what do you say? Like, how do you answer it? Or
Yeah, then that's not a solution. Yeah, it's not a solution to the system because it doesn't work in both.
okay, so that's the same problem I had in number 6 because one of the first equation worked and then the second one didn't work. So that means addition.
Now to tell you to be careful, number 6 is supposed to work in both.
Yeah.
Just to let you know.
Well, I plugged in for the second equation and I got it didn't add up. I don't know.
It'll work. Try again. Take a look. It should work.
Okay.
Just to let you know. Let me get this. Can you do wait for?
The practice test number 5C.
Oh yeah. So there were a few problems in the homework that looked like this. Said find the x and y intercepts, and the equation only has one letter in it. Because you're talking about this one here.
This is from the practice test?
From the practice test. How do you find the x and the y intercept? Yeah, so to find the y intercept, set x equal to 0. If I set x equal to 0, what does that become? And this is where you guys got to have a little faith. There's no x there, so what can I make x?
The y?
Any damn thing I want it to be. If I make x 0, what's the equation? Y minus 8 equals 0. If I make x 28, what's the equation? Y minus 8 equals 0, right? You see what I'm saying? So it's sort of like I don't have control because there's no x in there. So that tree out there, if I have, there's a tree out there. Let's say it's 15 feet tall. I have nobody standing over there. Can I say, cut that tree down? Will it happen? No. I have to have somebody there. So I don't even have x in this equation. X has no control over that equation. So if I make x 0, that equation's like, whatever. It's the same equation now, right? So what do I get for y? Y is 8. So the y-intercept is 0, 8. What's the x-intercept?
What number is this one?
8.
This is 5C on the practice test.
Oh, okay.
How do I get the x-intercept? I make y 0. And what do I get when I make y 0? 0 minus 8 equals 0. I get negative 8 equals 0. Is there a solution? No. So is there an x-intercept? No. So the easier way to do this problem, so of course, just like a math teacher, I took you the hard way. Here's the easy way. This is a special case, isn't it? Y equals 8. Who knows what kind of line that is? What would it look like?
A straight line.
Horizontal, exactly. Y equals 8. Y can't change, so it can't go up or down. It's got to stay like this. So y equals 8. If y is up here, can there be an x-intercept? It never comes down there, right? It's like a plane. Does it ever hit the ground for a while? No. You know, eventually it comes down, but right? Or what's better? The moon. Does it ever hit the earth? Not that I've seen yet. Right? It's always up there. So it never hits. It's always parallel, so it has no x-intercept. This is what the math would look like. But if you understand that that's a special case, it's quicker. You can just say there's a y-intercept, it's that, 8. But there's no x-intercept. So if I had an equation like this, which intercept exists and what is it, and which intercept doesn't exist?
X equals 3.
Yeah, x is 3, that's the x-intercept. What's the y-intercept?
Or is it 1?
None. I like it.
Okay.
Because now it'd be like this, it never goes over to the y-axis. It's always straight up and down. It never bends over to hit the y-axis. Cool. Those special cases suck when you try to attack them like you would another line. Because they're weird cases. One has 0 slope, one has infinite freaking slope. That's a little weird. Okay. Anything else? Any other questions?
Can you do homework problem?
Sure.
Okay.
I'm open. So again, you guys, if we're discussing something you totally understand, you got the practice test you can work on, the quiz questions you can correct, if you need to correct any. Yeah.
On 4.2, number 18, 4.2.
So it says substitution method. On the surface of this, it looks pretty simple. In fact, they've already got it set up beautifully. Which variable am I going to plug what into with the substitution method?
I'm plugging X.
Yeah, I know x is this, so we're just going to plug that in there. It's the result that freaks us out. The process doesn't change. So what do I get? 2 times
1 minus 5y equal, or
Careful.
plus 10y.
Okay. And that's, I'm glad you kind of said that, because very often we'll forget the poor other dude back here. Twice x plus, don't forget this plus 10y. Equals 3, good. So I rewrote twice x plus 10y. Everything stays the same, I just replaced x with what I know it to be. It gave me enough information there, right? Now you just solve this equation.
2 minus 10y plus 10y equals 3. And those cancel out and you get 2 equals 3.
So what's math trying to tell you here? What's the solution?
There isn't one?
This is never true, therefore there's no solution. What must be true about these two lines if I graph them? Didn't say to do this, but just let me just ask.
They have to intersect? No?
If they intersected, there would be an answer there.
Yeah.
If the answer is where they intersect and there is no answer, they must
Be parallel?
never intersect. I like it. Right?
Okay.
Is that cool?
Mhm.
So this is kind of neat. This is the big thing about mathematics is there's a lot of problems that are easier to do geometrically, and there are a lot of problems that are easier to do algebraically. And this is a really good fundamental example of how to do it in one or the other format. Some of them are really easy to graph. Some of them we've seen the answer could be ugly. I don't want to graph it.
What does that mean when 2 equals 3? That means,
So, never true,
okay.
no solution.
So we just write no solution?
Yep. And to let you know, this would officially, who knows what this would be called? What kind of system of equations? What's the name? There's no solution. I don't care too much on the test, but what would it be called? Does anybody know? There's consistent, inconsistent, or dependent.
Inconsistent.
Inconsistent, because they never meet, right? How much do I care about the name? Not too much.
And then what is dependent?
And it sounds like most of us are happy, but I don't care too much about it. Dependent would be if they're really the same line.
Okay.
Like for example, I said I'm twice as old as him, and he's half as old as me. Those are dependent because they're really the same stupid thing, aren't they? Do you guys get me?
Yeah.
Okay.
And then
So that's
when
why
I
they call
did-
that dependent.
When I did
And again, I don't care too much about that. I just care about tell me there's no solution. That's good.
Okay. And then when I did number 21 for section 4.2, when I plugged back in my answers, it didn't equal the same thing.
Oh, okay.
So I don't know if we could do that one also. Because that one looks simple too.
It looks a little ugly because it's got those fractions in there, but you see pretty quickly
But it tells
that's
you
not
what
a
y is
problem.
already.
Yeah. Y is the multiple of 3 of x. That makes that pretty simple, right?
I just have a
Oh.
question
Oh.
about that.
Yeah.
For the top part where it says 10y and when they cancel out, the 10y's, wouldn't the proper way to do it, wouldn't it be to take out -2? I'm sorry, subtract -2?
You could.
And then it would be what?
0 equals 1,
Okay.
which is still not true.
Oh, okay.
Right here, I could add 7 to both sides. I could subtract 20. I could do whatever I want to. They're never going to equal each other because they're always going to be 1 apart.
Okay.
All that matters is that you end up with the statement that is never true.
Okay.
You could get the 2 over, but it doesn't really change anything. Cool. So here, they do tell me again to use substitution. So it's pretty obvious again on this one what first step to take.
Plug in y.
Yeah, you could, actually if you wanted to, you could first clear the fractions out of this equation. But I noticed that there's a 3 there that when I plug it in for y, it's going to actually make that fraction go away. So it's a little bit easier than it looks. So if I rewrite number 1, I get 1/2 x plus 1/3 y,
3x.
but y is 3x. So the beautiful thing about the 1/3 and the 3 is
They cancel
they
out.
kill each other.
So it doesn't become 1, it just cancels out? Or
Well, it becomes 1, but I get 1x.
Okay. I didn't
How
carry
we
the
doing so
x
far?
over.
Yeah, that x has got to come down. The 1/3 3 is 1 times the x that's there, so it's still got to be an x there. But the 1/3 and the 3 definitely kill each other.
Okay. So then you end up with a whole x equals 3? No.
Half x plus x equals 3. Now, if you really want to, you can certainly get rid of the fraction. It's easy now.
Multiply by 2.
Multiply by 2. The only denominator there is 2. So if I multiply everything by 2,
And that's how you're going to get x by itself?
well, at least it kills the fraction for right now. And now it looks a lot better, right?
2.
You didn't have to do that. What's a whole x plus a half of an x? 3/2 of an x, right? And then you can multiply by the reciprocal if you want to. But you can always kill a fraction in an equation, because you can multiply both sides by that denominator, right? Okay. So you get 3x equals 6, x equals 2, and now you plug that back in. So either one, obviously I'd plug it in here. Y would be what then? 6. 3 times 2 gives me 6. Yeah. Wait. Do you have a different question?
No, no. It's four.
Good.
Is that, you canceled out the 3 and the, or that, are those 2 3s? You canceled out?
Yeah, right here. 1/3 of 3 is gone. Cool.
Yeah.
What page? Same page. It's at page 263.
What's the 2 next to the X? In the first, like, X.
Here?
Yeah.
Alright, that's when I got here. And I wanted to kill that 2 there. So I multiplied everything by 2.
Okay.
Cool. Yes, sir.
Page 269,
18? 18.
yeah, 269, page 18, yeah, I'm 18.
What equation should you use on the last one?
Y equals 3x here.
Oh, okay.
Because it's already solved for y. That's the nice thing about substitution method. You're always going to have an equation already solved for the other letter. So once I get x, I can plug it in there to get y directly.
But it doesn't always give you it that
And then
easy.
multiply the equation 1 by 6.
Yeah, you could multiply by 6 in the first place. That's fine. That'll work out beautifully. Nothing wrong with that. So if you want to, the very first thing on a system of equations, if there's fractions anywhere, you can very first step, you can multiply by the LCD.
And you can do that on both equations?
So I'll get 3x plus 2y equals 18. Do I have to do anything to the second guy? No, he's fine. And then you can do your plug in 3x there, work it out. It'll still come out to be the same answer. It's just no fractions then if you want to. Anytime you have an equation anywhere and you don't like the fractions, you can kill them. Because you have 2 sides to balance you out.
You kill them with the number.
You kill them by multiplying by the LCD. Because it will definitely cancel with each bottom. Because the LCD is the thing that has all the bottoms in it, right? So that's why multiply by the LCD works. Cool. I have a question on page 269. That's section 4.3. Number 18. So of course, 4.3 is all about the elimination method. Some books call it the addition method. What's the main idea on that elimination method? What do I want to have happen?
Cancel one.
Combine them so that what happens?
Cancel one.
One of the variables goes away. Because the whole problem with either of these is there's too many freaking variables, right? If there were just x's here, I could solve for x. If there were just y's here, I could solve for y. But they have an x and a y. Dingo. So I love the elimination method because it's so direct. It says, get rid of the damn thing you don't want. Why would adding them as they are right now not do much for me? If I add them right now, does anything happen? Nothing cancels, so don't do it. So often people, the first step they do is they add them and then they go, I'm not sure what to do from here. I wouldn't know what to do from there either. So you want to first set it up so that something actually cancels. What I would probably eliminate, which letter would you want to eliminate? I would say Y for 2 reasons. It's already different signs, right? They have to be different signs so that they'll cancel when you add them. And smaller numbers, what the hell, right? But the different signs is a big one. So when I multiply by negative, it's really easy for me to make a mistake and forget to do it somewhere. So I try not to as much as I can. So what would I multiply this one by and this one by to make it, what's the LCD kind of thing here? 6. I can make both of these become 6. And I want them to become one to be -6 and one to be +6, those they will cancel. Right? That's not the symbol. I don't know what the symbol is.
Eliminate.
Like that? Cool. So what do I multiply 1 by?
2.
Good. Multiply by 2. So let's see what we get. So if you want to, you can put a little 2 next to each one.
how do you remind yourself of that, like, to know if you chose 6, like, I don't know how to remember.
I didn't choose 6. I chose to kill the Y.
Okay.
And then I just do whatever I have to do so that they end up being the same number.
Okay.
So that's why it's exactly the same idea as LCD. Because LCD has the same problem. There are 3 and a 2, and I want them both to be the same number. 6. Right?
So you just figure out what they could both be.
What they could both multiply up to be. Cool. So if I multiply this first one by 2, I get 8x, 6y, 38, good. What do I multiply the second one by? 3. So what do I get when I multiply this by 3? I get 9x plus 6y. 72, yeah. So now if I add them together, what's going to happen? Here I get, careful, it's 8 plus 9, so 17. Those I set up so they will cancel, equals what's negative 38 plus 72? Something. 34.
And so are you always going to multiply, like you multiply by 2 by the first equation, and then you multiply the other equation by the other number?
Well, because
that'll get rid of it.
what's the LCD of these two? Why is it 2 times 3? Why is the LCD of that 6? Because they don't have anything in common, right? So if I had an equation, and we're not going to do this because it most likely won't work. If I had an equation like this, that's ugly. If I wanted to kill the x's, what's the LCD there? Between 8 and 6 is not 48. It's 24. Right, I can multiply that by 3 and that by 4. If you multiply it up to be 48, it'll still work, but the bigger the numbers get, the more likely it is I'm going to make an error in there somewhere. And the errors you can make on these suck so bad, right? Because you can get an answer like 24 over 11. You're like, what the hell? When it really was supposed to be 24 over 12, which is 2. 2 is awesome. 24 11, not so awesome. Do you guys see what I'm saying? So that's why you want to be really careful about this. So they're already different signs. And the LCD would be 24. So I'm going to multiply each one by what it takes to make it 24. And make sure that they stay opposite signs. Cool. So to finish this one out,
Divide by 17.
divide by 17. X equals 2. That's nice. And then how do I get the y?
Plug it
You
in.
just plug in the
Plug it
number.
in. So I would plug it into the second guy. 3 times x, which is 2, plus 2y equals 24. 6 plus 2y is 24.
Minus 6.
Minus 6.
18.
2y is 18. Divide by 2. Y is 9. So my answer is 2, 9.
Will we get it wrong if we don't put
No.
it in a point?
As long as you make it easy for me to find x and y, you're okay. If you write it like a point, a little tear will come out, I'll be happy. Because that's the idea, is where those two lines would meet. And they would meet at a point. But if you give me x equals 2, y equals 9, you circle them, I'm still happy. I just no tear. Right? No tear happy. I'll be happy. Yeah.
Could you do some examples, or one example, using the whatever was in 4.2? The substitution method?
I'm sorry. I
Sorry.
just love that question.
I was trying to look at my
Use some of
homework.
those ideas. Talked about
But with
last
some
time.
fractions, like can you
It's a
show
problem.
me how to,
The substitution.
yeah,
All
with
right.
fractions.
And that was sort of like what we did here. There was one with
I know, but
fractions.
that one was easy.
It wasn't
'cause
too
it gives
bad.
you what y was.
Do you have a specific one that's ugly? Okay.
24, 27, and 30? No, I'm just kidding. We need to do 24.
24? All right.
Yeah, yes.
24 is a really, oh my
Any of
god.
them.
Aw.
Yeah, did we get to see something?
24. Everybody see that red mark?
Yeah.
Yeah? Okay. Just, 24,
262.
this is section 4.2. Now, on this one, just to remind you guys, it says solve using substitution. So in the homework, be very careful that you use the method they say. Even if it would be easier with the other method, I don't care. They just want to make sure that you can fully use both methods. What's a good suggestion for what to do here? There are two main different ways you can approach this problem. One is the way it is. Substitution means solve for a variable, so I can just pick a variable and solve. If I do it that way, I might end up with some fractions involved there still. That would be really kind of ugly. What can I do very first thing to both of my equations to make them easier?
Multiply it by 6.
Yeah, multiply both of these actually, yeah. So if I take the first one times 6,
Wait.
let me write the whole thing out here so you guys can see it's happening.
Ours, we chose 6 because they both go under.
Because 6 is the bottom. Yeah. So that'll kill those. So here I get x plus y equals 6. Well, that's nice. And on the second one, I can multiply still by 6, because again, it's 2 and 3, so the LCD is 6. So I get 6 times negative 1/2 x plus 6 times negative 1/3 y equals 6 times negative 5. Yep, good. So 2 goes into 6.
Wasn't that a negative 1/2 on that?
It is.
one?
Oh, it
Okay.
still is. It just kind of melded together.
Okay. So negative 3.
So you get negative 3x, good. 3 goes into 6 twice.
2y.
So minus 2y, negative 30. So that's my second equation. So I'm working with this guy and this guy.
Okay.
So whenever you have an equation, you can come in and change it by multiplying both sides by whatever the hell you want to except 0. You can't make it 0 equals 0 and move on. Right, unfortunately. So in this case, I certainly didn't want fractions in my way because I got to solve for a variable and then plug it in the other one. And if there's fractions inside a fraction, maybe not. I don't want to do that. So I go ahead and first step, before I even do the solving of this, I just clean up the equation they gave me. They gave me ugly ass equations. Let me clean them up. Now that looks much nicer, right? What variable would I solve for from which equation?
The first one.
First one,
And whatever.
either one you want, because they both have a 1 coefficient. If I solve this for y, won't I get more fractions again? Right, if I try to solve for y?
Yeah.
1 divided by 2 under the 3 makes 3 halves, I have another fraction. Which if you had to, you should be able to do. But I don't have to. So I'm going to stay away from where I make my mistakes. I don't care how good at math you are, the more fractions floating around, the more chance there is you're going to make a mistake. So don't let them float around.
So the second equation, you multiplied by 6.
Because what's the LCD? So whenever you have an equation with fractions, LCD, if you multiply by it, it must kill all of the bottoms because it has all of the bottoms in it.
Is that a 3 above the 6 that you're multiplying on the second equation, right there? Above it? What is
Yes,
that?
because 2 goes into 6 3 times.
Oh, okay.
Cool.
So that becomes, that's a 3x, and then
Negative 3x, yeah. 3 times negative 1, negative 3.
negative 3x.
3 goes into 6 twice, negative 2. Cool. So I'm just reducing each step here. Yeah. Now, if I take number 1, and what do you want to solve for? X, I like it. So what would you do here to get x by itself?
Subtract y.
Subtract y.
X equals 6 minus y.
First thing I heard was you wanted to solve for x. It's cool by me. Subtract the y over. What do I do with this thing now?
Plug it in to the second equation.
Plug it into the other one. I like it.
Keep going.
So do you see why? Especially if you're at least as messy as I am. Even actually, no matter how messy you are, you should number these damn things. So you keep track of which is which, especially once you start multiplying them and doing stuff. I want to know which is my first one, which is my second one. So I rewrote my first one, I better plug that into my second dude. So how can I rewrite number 2? Negative 3 times,
6 minus y.
beautiful, because x is 6 minus y. So negative 3 times x, which is 6 minus y.
Minus 2y.
Minus 2y, good. Don't forget that poor little dude.
Equals negative 30.
A bunch of negatives, I like it.
Yeah.
And now that, right there, is easy to solve. Should be. So you adjust. Bring that in.
Negative 9. No, I'm just kidding. Negative 18.
Don't joke that day. Negative 3 times negative y.
Plus 3y.
Plus 3y. Minus 2y.
So now I just have y equals.
Add
Good.
18 plus.
Add 18. This becomes y.
Oh.
13.
Negative 12.
Okay.
Oh.
But, and the really nice thing, again, this is substitution, so I know I have an easy equation to use. If y is negative 12, what do I plug that in to get x? X equals 6 minus y.
So x equals 18.
Yeah, so if I plug that in here,
18 negative 12.
17.
That was easy. Huh.
all right. So again, you don't have to be loving this or awed by it or whatever. I just want you to understand. This isn't anything too major. I think as students, we're not really sure how much flexibility we have. When am I allowed to do this? Anytime you have an equation, anywhere, you can kill the fractions in. For whatever reason, and most of the time it makes it easier.
Okay, you multiple both by 6. So you multiple both by 6 or because you fill the fraction with the second?
Because each one, 6 worked for each one happened.
So,
You don't have to multiply them both by the same thing.
Oh,
If this would have been 1/12 plus 1/12, I would have multiplied him by 12 and him by 6. It just was a coincidence that 6 worked for both. In fact, we had a problem earlier where I multiplied one of them but not the other one. You definitely don't have to do the same thing to both equations. You have to do the same thing to both sides of one equation. Yes.
My biggest fear is not being able to figure out what number to multiply each equation by. Other than I understand the LCD thing, but like,
There you go. That's it. If you can see the fractions and you know what the LCD is, that's what you multiply by. That LCD, that's it. And you multiply, do it just like this so you don't forget anybody, right? Put that number next to each piece.
yeah, I definitely will get lost with the fractions, so.
Okay, so kill those.
I could answer the practice test.
Yeah. Hey, let me go ahead and give these out to everybody.
Are you going to send my quiz? My quiz? Did I get it?
Oh, yeah, yeah, just a second. Oh, you already got one. Oh, that's your head's out.
Yeah, I see.
Okay. Anytime.
Is that the practice test?
It's a PDF.
Yeah, I have a question real quick.
Okay.
On 27, it has 1/6x plus 1/3 y. So to get the common denominator, times those two by 2 to get into the 6.
No. So, you can't multiply parts of an equation. Whatever you do to one side, you have to do to the whole other side.
Okay.
So you
So I
want to
have to do
multiply
it
by a number. Yeah, 18. Well, not 18.
Well, no, but you'll time, I don't get it.
So if I have 1/6x equals 2, how do I solve it?
I don't know.
Yes, you do. Think about it.
Times it by 3?
Not 3.
I don't know. I hate
I want to get x by itself, so how do you kill the 1/6?
times it by
6. So that's the same idea here. It's just a few more things in it, right? So now it's a little more involved. This is not just one bottom. But the LCD for this and this is 6. So we multiply each thing by 6. Because nobody can escape.
Okay.
Right? Because I would distribute the 6 to everything on this side, and this side has to have the 6 also.
Okay.
So that would cancel there.
So you're left with X
3 goes into 6.
twice.
So you have 2y equals 6 times a. That's the idea.
Okay, so then for the bottom one, you would just do the same thing, but you would
Multiply
times it
by
by 4?
4. Yeah.
Okay. Thank you.
All right. So double check me. I think I got these right. Be really careful about. I hate when people do like a problem like number 8a. You graph the lines beautifully. You just forget to tell me the answer. The whole point of the question is, what's the answer? The answer is the point where they meet. So don't forget to write the point. I'm always like, damn, you almost got it. Obviously, I won't take off full credit because you did some work, but I will take off a decent chunk because the whole point is to give you the answer. Let me see, anything else tricky up here? So like I said, I'm going to give you a couple where I say definitely use substitution, definitely use elimination. So you must use the process that I asked for, right? On the ones where I say solve it graphically, if I'm you and I like the algebraic way better, you still have to do it graphically, but I would sort of do the algebra on a scrap piece of paper just to make sure I'm going to end up with the right answer, just to know what the answer is. Right? Nothing wrong with that. You still have to show me the graph, but kind of get an idea what the answer is going to be. Do you understand 1b? Do you guys have, is that okay?
Oh, like you want the point A and B, like. do
Well, the slope between the points A and B. So the point A was 0, 2, and the point B was -3, 5. So I showed you the slope work, but you could have just counted down and over. You already graphed them, so you could have just counted down and over. Is that cool? Let me put this up here real quick.
Are you gonna have a question like that?
That might be why I'm making a point of this.
Okay.
I might have a question like that.
Makes sense.
Let me just point this out. This is fence. Yes?
On number 3 here, would it be a problem if I only did 2 points? Did I see you got like...
Oh yeah, I just did 4 just because. If I don't specify, 2 would work, but I would do 3 just to be sure. Yeah. Okay. So real quick on this one, here's what I mean. I didn't bring any pen. Oh, did I? No. Oh, well, too bad for me. So here's for number 1. Over here it says find the slope between the points A, B. So I want to have this slope here. So you can actually just count 1, 2, 3 down, 1, 2, 3 over. -3 over 3 is -1. You get the same answer.
So if we do that, we don't need to put the Y.
You don't have to do this work here, no, because whenever you have it visually, you can just count rise and run. That's the conceptual use of slope. This is the more algebraic way to get slope. Yeah. Okay, cool. Somebody's asking me, I used 4 points here. You can certainly just use 3. You only really need 2, but I would do 3 maybe just to make sure you're on the right track. If you don't end up with a straight line, something has gone wrong. This kind of equation must be a straight line. Anything else on here kind of standing out to you guys?
If you do the graph, the equation, the inequality for the ball, number 7.
7.
I like sheet graph. Just to make sure, like, I know what side of the graph.
So I decided, I almost didn't show any work, but I decided I should show some work. There's the inequality there, written in y equal mx plus b form, right? What's my intercept, my y-intercept?
-2.
-2. And my slope tells me to go
Up 1
up 1 over 4. Why did I make it a dotted line?
Because there's no line under the.
Because it's less than, not less than or equal to. I love it. So it's like an open circle, same idea. So be real careful about that. And some of the homework I graded, some people are making it everything solid line, but if it's strictly less than or strictly greater than, you've got to make it dotted. And then I showed you the little test point work here. I plug in 0, 0. Is 0 less than 0 minus 2? Is 0 less than -2? No.
So you don't include it.
So I better not go this way. I better go the other way. 0, 0 didn't work. It must be on the other side of the line. Cool.
So, like,
That's the all or nothing situation, right? That test point is all or nothing. Yes, ma'am.
Page 2, like number 8, real quick, just how you got from the first equation and the second part.
Oh, yeah. Now, there I did leave out some steps. Number 8, right? 8A. So let's see, it's 2y plus x equals 12. And y equals 2x plus 1. So here, to get y by itself, you would just
Divide by 2.
not
Dividing
quite.
the y for 2.
Yeah, get rid of the what first?
Subtract x.
Subtract x. And see how I'm throwing that negative x right where it's supposed to be? mx plus b. So let me put the x piece first, right?
so you divide by 2.
And now I divide by 2.
So,
What's understood to be up here?
1.
There you go. So again, with -1/2 x plus
6.
6. That's where that came from. See number 1? -1/2 x plus 6. And of course number 2 is already in mx plus b form. It's mighty nice of your teacher.
Is that it?
And now you've got to graph it, right? The whole point of that is solve it by graphing. So the first step is to get it in the mx plus b form. Now if you want to, you could graph just the intercepts. But the problem you have then is, if I have the slope, I can count more than one step, and then it's easier to see where they meet. Right? If I just do a line here and a line there, and I'm like, where the hell is that? I can't tell where that is. But if I'm counting up and over, I really know where I am. So that's why and you need practice with mx plus b. So solve for mx plus b form and then graph it from there. It'll make it a lot easier. Yeah.
Okay, so like number 15 on the homework, I know it's supposed to be either, but x minus y equals 2, and then
Where are we at? 4-3? 4
for 1,
4-1. Okay.
number 15 on page 253. So that one is pretty clear, like you could substitute the y part, but how am I supposed to know which one is exactly
Oh,
which
page
equation?
250. This one here, right? X minus y equals 2. This one? So see, very often, once you've done a later section, you desperately want to like eliminate, but no, we want you to do this graphically, right? That's not your question. Your question
Yeah,
is, I mean, how do I solve, number 1, I need to solve for y, right? How do I get y by itself?
So you always just solve for y?
Yeah.
And
No, and how could I say this? There's always another way or more meaning than what we teach. Because there's stuff you can come up with yourself. There's a lot of things I developed that none of my teachers ever told me, but I just made it for myself. So you might never see in a book, but it works. The funny thing, I really don't want to teach a lot of this because it gets confusing with the main idea. We could have done this. But can anybody tell me what that would be now? It's not the same as it was up here.
Why not?
X and 0.
Because why is this the y-intercept? Because how do you find the y-intercept? You make,
Why?
how do you find the y-intercept? You make x0, and what do you get? Y equals b. Now look here, when you make y0, you get x equals b, so that would actually be the x-intercept. So in one way, we had to choose one way or the other to go. And we decided to make x my inputs and y my outputs. We could have went the other way. And to tell you honestly, in later math courses, you can do it whichever way makes more sense. But for right now, just to get the idea, we stick with this. You kind of with me here?
Yeah.
So that's why we always solve for y, because we're building everything on that rise run. If I solve for x, now it's run over rise. Holy shit. I don't want to have to memorize, okay, in this case it's this. No, let's just make it rise over run, right? So let's always solve for y. So that's always the y-intercept, and that's always the rise over run. But it's a good point. You could do the whole thing the other way. Well, let's not. That's a little too much to kind of keep in our heads right now. So yes, you could always solve for y to get the information you need for your line, right? Because now if I divide by -1, y equals x minus 2, what's my slope?
1/1.
Good. 1/1, because that's what's here. And what's my y-intercept? Yeah, 0, -2. I love it. So then you can graph that line pretty easy. I start here, go up 1/1, up 1/1, up 1/1, up 1/1.
So what about the other line? That's the next
And then
line.
do the other line, same thing. Yeah. So get that line drawn, and then on top of that, put the other one and see where they meet. Cool. Okay. I can tell I've given several of you headaches.
So when we answer questions like 15, we would write out slope equals.
No, the answer to this question is a point,
Oh, okay.
right? This, I'm not anywhere near done, really.
Oh,
I mean, to finish this out, again, to graph this line, -2,
you go up 1/1.
yeah, up 1/1, up 1/1, up 1/1. Just do that a few times. And what about the other line? That one's a little easier to solve for y, right?
So is that when you subtract x again from that?
Yep, subtract x. So you go y equals -x plus 6. Oops. What's the y-intercept? Good. 1, 2, 3, 4, 5, 6. And it tells me to go down 1/1, down 1/1, down 1/1. So I can keep it straight. Down 1/1. Looks like it's going to be right there, right? Up 1/1 is there. Down, see, so that one I really had to step out far ways to get it. You guys see that? So if I don't step over enough, I just go ahead and take one more step maybe, or a couple more steps just to see where they meet. So what point is that? Yeah, this is the point 4, 2. And sure enough, 4 minus 2 is 2. 4 plus 2 is 6. It works. Cool. So that's what I mean about step out with the slope, more than you normally would, so you can really see where they meet. I didn't even step out enough. I was like, shit, that wasn't enough.
In the second equation, what did you plug in? I'm sorry, I missed what you said.
Second equation, solve for y. Just like always. Anytime I want to graph a line, the quickest way is to solve for y. Because then I can see my y-intercept.
Okay.
And my slope, negative 1 over 1,
So that one is down one. Okay.
down 1 over 1, yeah.
And that cross is at the 6, okay, I see it.
At the 4-2 point, yeah. So make sure on your homework or your test, make it easy for me. Write that answer down. That's the key part, not just the picture. That's pretty. I want to know what the answer is. Okay.
And that cross is at 4-2?
Yep. Any other questions? Deep breath. Yes.
For this problem right here, earlier you were teaching us how to do the 2 and then plug in the y, which is 2x plus 1 on the first equation.
Oh, substitution.
Yeah. So
Yeah.
that's only one substitution though?
Yes.
Oh.
So, but like I was saying, if I ask you on the test to solve a system of equations by graphing, I would do the algebra real quick, just to kind of know ahead of time what I should expect. You know, if the answer comes out to be 7, 3, then I know I got to go way over on my slope, way out to 7. Do you see what I'm saying? So it's not a bad idea to do the algebra on a scrap piece of paper. You still have to do the graphing, but at least you know what to expect, what answer to expect. You see what I'm saying? So if I go in and I know the answer from algebra should be 1, negative 1, and my lines are doing this, I graph something, either my algebra is wrong, or I graph something way wrong, right? Okay. So it's not a bad idea to kind of check yourself with algebra. There's a graphical method and an algebraic method. Check it with the algebraic method. Any other questions? Yeah.
Number 3 from 4-2.
Number 3?
30.
30. Oh yeah. So this one's got our other favorite thing, which is decimals.